you spoke about how you want to ask the most fundamental questions. You want to be nosy in a way. And there was this sustained effort after Bohr and the Copenhagen interpretation where these type of questions are not encouraged. You've shared a story from your life where I think in undergrad you had signed up for your first quantum mechanics course and you had raised your hand in the first class to ask a question about the foundations of physics. And the professor immediately shot it down in an attitude that pretty much said, shut up and calculate, right?
Yeah, well, yeah, it wasn't the first class. I mean, actually, this was in the middle of the class. I mean, we'd done quite a bit. And we were learning spin and you learned these matrices and how to, mathematically manipulate these matrices and so on.
Yeah.
So it certainly didn't come up in the first day of class because they wouldn't bring it up. What's really going on? I mean, from the beginning, here's a bunch of math, here's how to solve a Schrodinger equation. Here's what an eigenvalue is.
Yeah.
Here's how to manipulate that to make predictions, all the standard stuff. The standard stuff doesn't put you even in the mood to ask these questions. But it was in the middle of the class and we were talking about spin and the effect of magnetic fields on particles with spin. And I was trying to form a very concrete physical picture in my head of what was going on. And so I just put up my hand and said, is it like this? And sort of described this picture in my head. And it was at that point he said, no, it's not like that. And then didn't, as I say, he didn't go on and say, think of it this way. Think of it, here's a better picture. It's like, no, there's no picture. There's no comprehensible way to grasp what's going on here. Just get on with the calculation. And what can you do? I mean, if that's what your professor says, you're dissatisfied.
Yeah.
And this is absolutely common. I mean, I teach philosophy of physics all the time, and we get philosophy students and I get physics students. And it's just very common for the physics students to say, this is what interested me in physics. This is why I went into physics, was to ask these questions. And I'm not getting this in my regular classes. This is just commonplace. It's not anything that's questionable or, outrageous to say. Any physicist, anybody who's gone through a physics education will tell you that. I just gave a talk in Johns Hopkins, and it was about Bell's inequality. We'll get into that and so on, and kind of an exposition of it. And after the talk, a guy put up his hand. He said, I have a training in astrophysics, and none of this was ever explained to me. I mean, that's all he said. He said he wasn't objecting or anything. He just said, I learned quantum mechanics. I learned this. Nobody mentioned this. Nobody explained this. And you're saying, well, that's the way it is. Somebody ought to be doing it.
Why do you think that is? Like, if we had to dissect this shut up and calculate phenomenon as a case study and track its evolution, you've often mentioned that historically physics and philosophy was the same thing. Aristotle was a philosopher. You've said Isaac Newton would have considered himself a philosopher. So how do we get here from that synonymous coupling between physics and philosophy being the same thing to now this clear deviation where you have the shut up and calculate mindset on one side and you have philosophy on the complete other side?
You really have to trace it to quantum theory. If you look at the modern physics, even go before Einstein, so somebody like Maxwell or somebody like Boltzmann, these people were again asking exactly these foundational questions. I mean, Boltzmann was a committed atomist, and at the time, atomism was not accepted generally. And then he said, well, if in fact particles are, matter is made of atoms, if gases are atoms, what'll happen? How should they behave? How do they bounce? What can we show about what their behavior should be? And worked out a lot of thermodynamics that way. And Maxwell and the early people working in electromagnetic theory all of a sudden said, gee, we need to introduce these new objects, fields, electric fields, magnetic fields. They're not like anything that Newton ever thought of. But look, we can introduce them. We can write down some equations. We can see how they behave. We can connect up that behavior. You can now make radios and so on. Special and general relativity can also be understood as just very clear postulates about the fundamental structure of space and time. And general relativity is providing you a different account of gravitational phenomena, but one where you understand what the theory is claiming. I mean, in this respect, although many people think of both relativity and quantum theory as somehow mysterious, the situation is entirely different, because the more you work with the general theory of relativity, the better you understand it. The people who are really experts in that, you ask them a clear, concrete question, they'll give you a clear, concrete answer. According to the theory, this is what's going on. This is how to think about it. Mm-hmm. Whereas in quantum theory, the standard physicist has no answers if you ask, what is this theory really claiming? And again, my psychological hypothesis is it's kind of embarrassing to be a professor, and when a freshman asks you a perfectly good question, you have to say, I have no idea. So it saves face a bit better to say, that's a bad question.
Right.
Right? The problem isn't me, it's you. And this was more or less what Bohr was saying. You're asking for something that cannot be given. We've reached the limits of comprehension in a certain way. It's not true. What Bohr said is demonstrably untrue. You can do lots of things he said couldn't be done. And there are these famous impossibility proofs we'll probably get into of von Neumann, a great mathematician telling you something can't be done. And then you wake up one day and say, hey, it can be done. Look, here it's been done.
Yeah.
So this idea of trying to squelch these questions, as far as I can tell historically, absolutely traces back particularly to quantum mechanics. Now, the irony is at another level, and this maybe for the last 50 years, many physicists have gone way off the deep end in pure untrammeled speculation about string theory and this and that, where they're perfectly happy to say things that sound like things Bohr would say. You can't even say that. Yeah. And then they just go way off into kind of mathematics and piling one thing on another. But at the same time, if you ask them basic questions just about quantum theory and how to understand it, they won't have clear answers to it. So it's a weird situation now.